Hello, everyone. Welcome to the second panel at Feature Store Summit. My name is Nick Pinkernell. I'm a distinguished engineer with Comcast, working on ML platforms, MLOps, and ML architectures as well. So in this panel discussion, which should be very exciting, we'll tackle some of the benefits of feature stores and who in the various organizations of the companies, of the folks that we have representing, will benefit from. We'll also chat about, the positive impact and maybe even the negative impact if we go there of feature stores, which I can't really think of any. But yeah, so with that out of the way, I'll introduce the folks who are on the panel. Some of you have already given some talks earlier today, and those were fantastic. So we have Mark Roy, Principal Architect of ML at Amazon AWS. We have Davor Banaki, CEO of Kaskada, and they're doing temporal feature stores, which is pretty interesting. We have Manny Parquet, Databricks engineer for ML, Patrick Doherty, which is co-founder and CEO of Rasgo, and Richa Sakdev from Vanguard, ML engineering manager. She just gave a panel or a session, excuse me, just before this. And then head of data science at Shelf Engine, Sean Ramirez. So welcome everybody to the panel. Glad to have you on. Okay, so I'm going to start off with a really easy one here, and we'll just go around. So Richa, can you start us off here? I would like to know, in your words, how your team or org is benefiting from feature stores at kind of a high level. And we just heard your talk, of course, but if you could reiterate that for the folks who are on now.
Yeah, absolutely. So feature store is definitely helping different personas. So starting from data engineers, where they have a lot of reusable data that they can productionalize. So their jobs become really easy for us to reuse the data. For my own team of machine learning engineers, the reusable components, the modular code that's already written to publish. So those are the best practices that are helping us. And the data scientists, it makes it really easy for them to use search and reuse the data. And it's also not just in my own department, but also across the board. It becomes really handy to be able to use it. So feature store is definitely our IP, and the data that we are putting into it just makes it readily available for business and data scientists and engineers. So overall, it's been a very positive addition to our toolkit.
Fantastic. Yeah, the data reuse piece is really quite interesting. We have a lot of data specifically that at Comcast that's reused and copied, and we're currently working on deduplicating some of those. So that's a good topic. So Mark, did you want to go? Benefits
Sure.
of the feature stores. Yep.
Yeah, so the way we see it with customers that are using SageMaker Feature Store, it really centers around a few main pieces. One is the same thing that Richard mentioned with reuse of features. So I mentioned an example earlier. We've got a company that has literally tens of thousands of features. So they've taken an approach to have kind of separate teams that build out common features on common data that cuts across, large business units. And that just saves a lot of drudgery and maintenance work that no data scientists ever signed up for. So I think that's probably, in my opinion, the biggest benefit is just not wasting time doing things that have been already done well in the past.
Nice. Yeah, agreed. Sean, what do you think the benefits are or are to your org?
We're in supply chain, and so one of the things that we try to do is connect supply chain models, whether they're demand or inventory models, at the sort of downstream impacts or upstream impacts to downstream or upstream connections in terms of like feature development. So if you're developing a feature, and it might be as simple as like how we use something like the weather or school events or COVID closings or something like that, how do we connect that into observability when we think about experimentation, and whether this set of models or containerized set of models that we're pumping out is affecting various accounts. And so we use Feature Store to make sure that those connections are really clean, and that that not just that the code is reusable, but that machine learning scientists who are developing these different models are speaking the same language as the people who are developing causal learning at the other end.
Yeah, that's interesting. The shelf engine use cases is quite different, I think, than some of our other use cases. So I would like to hear more about that in a bit. Manny, would you like to go ahead?
Yeah, thank you. That's a great question. So from the customers that we have talked to, right? So if we look at the spectrum of customers, like, you know, from finance and manufacturing to tech industry, travel, that used to be a thing, and like, you know, pharmaceuticals and stuff like that, right? So there's a huge spectrum of the kind of problems that they're solving, but they're very similar in nature, right? So like, you know, it's data science, lots of data, and some customers have like, you know, large teams of data scientists where they want to sort of reuse and share features, whereas some are like, you know, really small, like, you know, one person does everything and she writes the models and computes the features, like, you know, everything. So we wanted to sort of abstract out the complexity involved in computation of features, and like, you know, just using them for training, scoring, and even online and offline, like using a similar mechanism, right? And the like, you know, the kind of problems that we wanted to solve were like, you know, that like, you know, that people run into it most frequently, like, you know, shareability, discoverability, and then online offline skew. So I think with having a centralized feature store that an organization can share and different people can share, you don't have to recompute the same features or know if a feature exists before. So it sort of gives a multiple X productivity boost to the teams that are sort of generating multiple models or iterating on the same models, like, you know, with new data that is coming in.
Right. Yeah, that computational reduction is good as well, so that folks don't have to redo transformations or normalizations on input or raw features. Yeah, that's pretty important. Patrick, what are some of the benefits you've seen at Rasgo?
Sure. Yeah. So, and in terms of our customer base, kind of similar to Manny, we're seeing needs from customers across a lot of different verticals. Sorry, it's echoing. So in terms of like the benefits that are kind of common across those different industries, I kind of group it into three categories. So acceleration, kind of like Manny said, being able to reuse what's already created instead of creating it from scratch is going to save you time. System of record, so like the kind of governance and centralization aspects that large companies look for. And then finally, kind of like creativity, right? Like finding things you might not have had time to find otherwise. That's what a lot of our users say, like, because I'm not creating these pipelines from scratch and Rasgo helps me build those faster, I have more time to look for like features that might increase the accuracy of my model.
Interesting. Yeah, creating those features from scratch, that's certainly, I think, a theme that we'll see throughout many of the use cases. Davor, did you want to go ahead? What are some of the benefits you've seen?
Absolutely. It's fun to go last here. So I feel lots of things have been said, and I can only kind of concur with, you know, consistent feature definition, feature reuse, reducing costs, and things like that. But I'd like to double down on what Patrick has just said last. I think really it's about enabling a data scientist to be able to discover new things, to be able to validate and experiment and, you know, have hypotheses, and some of them will work and some of them won't, and that's okay, because if you try enough things, the model is going to be better. And so kind of from my side, something that solves the problem is something that enables a data scientist to experiment and iterate, because that is going to result in a better model. And if the system doesn't allow for that, that's kind of, you know, nice, but it doesn't make that right impact, in my opinion. So that enabling that iteration, enabling a data scientist to really focus on, you know, figuring out features and not dealing with pipelines is the key thing from all of the things other kind of fall from.
Right. Yeah, and that's very interesting. So for the next question, I'm curious to hear from everybody here, who in your org or team or use case, like who is working on and responsible for the feature store. This could be, of course, more traditionally MLOps folks or ML engineers, but I'm curious to hear if anybody has anything different as well, or if it's just kind of you've built teams, engineering teams and ops teams, and now those folks are shifting over that responsibility. Richa.
Yeah, so definitely we have MLOps engineers, ML engineers. My team is the one that's helping with the design, and then your architects who are architecting that. But we also have two other big bodies. One is the governance and risk, and the second is the data governance folks. So the first is around the model and the risk. So we have to make sure when we are using feature store to deploy our models, we are making sure that we are conforming to all of the protocols that they are setting, and we are capturing that when we productionize something and call it done. Specifically, the things that go through the MLOps pipeline feature powering through our feature store. And secondly is also the data governance aspect of it. How are we being the good data stewards for the ML assets that we are creating, which are our features and insights, and how we're governing that, how we're taking care of PII, how we're redacting that. We have call data, we have notes data, that's all unstructured. How are we taking into consideration the PII that's strewn everywhere? And the PII could be from just SSN to date of birth to even someone's criminal history, for example, or your health history coming in finance world. So we have to make sure that we're also using the right protocols to be able to govern the data, and we partner very closely with these two bodies to ensure that we are using the best practice in our MLOps pipeline using feature store.
Interesting. Yeah, that obfuscation piece, I think a lot of folks are doing that in a pretty standard manner, but that would be interesting to hear about more later, you know, in specific to the financial sector, how that may differentiate. So Mark, for AWS, folks who are, you know, responsible and working on those feature stores, I bet that's a bit different, right? Because you not only have everybody developing those offerings for SageMaker, but you also have feature stores presumably internally that you utilize, right?
Yeah, so of course we've got the service team that builds, you know, and creates the offering for other customers. And I think the way we're seeing it play out inside of Amazon, you know, for the thousands of models behind Amazon.com and other things is it's not quite a centralized store. I think it's more federated. You know, you've got lots of large feature stores, and they tend to own and operate within sort of some business unit or some group of teams. And we're seeing that play out in other customers that I work with as well. Typically, there's an ML platform team, and they're maybe moving on from an in-house do-it-yourself feature store. They want to adopt something that makes it easier for them. You know, the other aspect of ownership is really who really owns the features themselves. And, you know, one of the questions I saw you threw out, Nick, before the panel was, should data scientists really own that? And I think that's a pretty, maybe you're reserving that one for later, but in terms of ownership, I think that probably most data scientists are too creative in their DNA to want to be the person that builds something and then is on the hook for maintaining it. But I think there'll probably be a split at some point where you do have some folks that are really good at building things and building out common features, and then others that are more on the creative side and helping drive a lot of brand new features. Just something that is in the back of my mind in terms of how things play out going forward.
Yeah, ownership is a big question. Certainly, we have thousands of features in our feature stores, and is it the ops folks who wrote the pipelines and ingestion code who own the features? Is it the data producers, or is it the data scientists who are doing the various operations on those and feature transformations, right? So that's certainly a good thought exercise, I think, for folks. Sean, at Shelf Engine, you know, who's responsible for your feature stores?
So, I mean, we're a growing team, I would say.
Mhm.
And what that means is that machine learning scientists basically create the initial pass at the features. And I think, I very much echo what Mark said in terms of they're creative. And so there are some common standard things that they've wanted to create, and those have been easy to pass off to data engineers who can, as part of a growing MLOps domain, they will continue to maintain that because really they need to look into data drift or other aspects that are important to ensuring that those models continue to be useful in the real world. And the machine learning scientists themselves like to move on to other new creative aspects. And I think that's very normal. So in terms of like maintaining a long-term feature store, there's a team of machine learning engineers and data ops, ML ops people who include data engineers and other individuals with more technical skill to make sure that everything lines up correctly there. But they are not the initial creators of some of the more exciting features.
Interesting. Okay. Davor and Patrick, I mean, you guys build feature stores. Do you have your own?
We've been using Rasgo on Rasgo, we call it.
Okay.
So yeah, kind of using our feature store internally to inform some of the simple models that we're building out. Yeah, super important to kind of consume your own product.
Eat your own dog food, as it were, right?
Exactly.
Yeah.
Similarly, we also internally work on various dog fooding type of activities, but it's at that level. It's not that we run something in production on top of our system. But I'd love to kind of touch base on what was said earlier by Mark and Sean about ownership. It's a topic that I do really care about, and I will respectfully disagree with some of the things said here. So from my side, the ownership in some sense is shared. It is very hard for somebody, be it a data scientist, create something and say, okay, not my problem anymore. And that's something that, doesn't work for lots of people's career, right? Like we really in tech, in many other places, the results come when we actually make something of value, and that stands test of time. And so I do think that data scientists build models that are actually amazing, that want to work on them and actually kind of show impact. Machine learning models can generate millions of dollars of impact. So there are some companies that are working on it's a really core business. And I don't think data scientists working on those models want to move on. I think they want to be improving this model because that model is the lifeline of the business. But they often cannot do it alone because things are changing in the system. Data is changing in some way. Somebody changed some schema somehow down the line. So things do change. Data shapes, data formats, schemas, things do change. And so there needs to be a joint ownership of different parts of the system. And typically how I see success done is that you have a data engineering team that works on data pipelines and populating, let's call it a central data warehouse, where kind of canonical data is stored. And then the data scientist owns a portion from, let's say, a canonical data warehouse to feature generation, but not feature serving, which enables really the data engineering team to own the underlying infrastructure and data delivery, and then take the features and serve them in production. And enables a data scientist a very nice and clean loop from raw events, raw data, to features and models. And that is like a really clean iteration loop that enables data scientists to really iterate really quickly. And then data engineers can own everything around it with a really clean boundary between. That, I think, is the right ownership model that I have personally seen work quite well in a few places.
Right, and to that ownership model, I mean, if you have the versus say the actual data itself, I mean, what about certain regulatory types of concerns there, where some of your ops folks, maybe you don't want them having actual read access to some of those data sets, right? But the machine learning, the research scientists and your folks working on model training do need to see some of that. So I think that's an interesting point, and I think in a bit we can get back to that question, because that differentiation of roles and responsibilities and who owns that and who has access to it is pretty important. So Manny, at Databricks, who owns your feature stores?
Yeah, this is a fantastic question about ownership and empowerment, right? So I can, again, we build feature stores. We obviously use feature store for some internal modeling and tracking that we do. But I wanted to chime in a little bit from representing the customer's point of view that we've talked to, right? There's definitely some large customers that say that we want to build in governance into a whole bunch of APIs that we will write on top to sort of make sure that the entities fit a particular schema, or the features behave this particular way, or data is supposed to sit in a particular way, right? And there are definitely these smaller players that there was a particular person we talked to is they are the be all and end all of their entire team, right? So as a developer of feature store, what we want to sort of build out is these abstractions that people with different personas, like a team of a whole bunch of SQL analysts writing SQL queries, want to empower the team to generate features and to produce features for the machine learning training, right? Whereas the idea of enabling your data scientists to write production quality code and providing the right abstractions such that while they're experimenting, they're writing code in a manner that can be easily moved into production as it is, rather than having to spend a lot of cycles later on that, hey, this model works great, but if we we have to scope out a project for the data science, the data engineering team to take over, write it into another format, and then there's another team that comes in, and the MLOps team that comes in and writes it in a format that can be used for online scoring, right? So these add delays into different steps. So one of the opinionated approaches we take that giving power to data scientists upfront, such that once they experiment with the feature computation code, use that in the model, that model is ready to ship out into production immediately without having to redo all of the different steps in different environments.
Okay. Yeah, I mean, being able to quickly and easily move those between environments from dev to staging, production, those sorts of things. Very useful. So I have a specific question for you, Mark, at AWS, and then we'll get to some of the other folks as well. How is Amazon, aside from cost, benefiting from its own offerings? Like, are there any additional, kind of niceties or things that you guys get for free in consuming some of your own services?
Great question. Yeah, we certainly get discounts internally for using our own services.
Yeah.
That's a benefit. I think the other thing is we tend to get early access to things, right? Maybe you get to take part in private, but we do that with other, large companies and partners as well. I think the benefits are really the same as those that you'd see in any large company with a mature, ML practice, and that is being able to have a place to build and share these features without having to have a large ML platform engineering team. So we've seen, much smaller teams that are more data science focused with only, one ML engineer or a couple of ML engineers supporting many dozens of scientists be able to introduce this concept and start making much more, productive approaches, speed up the whole development cycle, as well as, one of the things that happens is we have an awful lot of online models that require super low latency. So that can be a little tricky to build on your own. So it's just one less thing to have to worry about.
Right. Okay. Yeah, it makes sense. Certainly when you have all of those tools at your disposal and you can build architectures kind of Lego block style from all, the various offerings. So and I'm sure the cost helps tremendously. So to Richa and Sean, with your unique use cases at Vanguard from the financial sector, and of course Shelf Engine, which is just super cool. How, what are some of the unique challenges you see or benefits of the feature stores from the financial sector and then from Shelf Engine? Richa.
Yeah, sure. Yeah, it's a great question, and something we have to grapple with it every single day is how are we storing the data? How are we consuming the data? How are we aggregating it? And how are we creating a documentation of it? Because there are a lot of governing bodies that audit how we store the data and consume the data. And we have, new laws coming in, CRPA, CCPA, so we have to conform to that as well. And a huge portion of it is how do we handle the PII, like I was talking to you about. It is relatively easy for you to be able to redact data when you are working in a relational database. But when we have a large amount of calls coming in where our sales folks are taking notes and emails are being sent around, and when we are using that to be able to create our models, we need to be able to handle that the right way. So data scientists, when they need to create a model, of course they need, let's say, the zip code or the age, etc. But there is really no need for them to be able to see someone's criminal history or someone's religion. So we have created an in-house redaction tool that would identify these classes. We call them as classes through name entity recognition to be able to redact them. And then when we eventually store that in the data lake, we have to have two different copies, one the original and the other is the redacted. And then when we also create features on top of it and embeddings on top of it, then we have to make sure that we are getting data requests to the right one. And then even then when we are surfacing the features as well, we want to make sure that we're not exposing more information that we need to. So a lot of the right practices of data stewardship is something that we have to work with our actual data owners who sit in various lines of business. And me as the data owner of the features, we have to make sure that I also understand these laws and rules, and we have constant checkpoints to make sure that we're conforming to these rules that are out there, or laws that different countries, for example, might have. And even Vanguard is not just in US, but in different countries. And then the rules change from country to country. So we also have to make sure that we have a centralized governance body that's keeping track of that. And anytime they are rolling out something new, we are able to go back and make those changes in our data as well. So that's why we created our in-house redaction tool that I was talking to you about. So those are just some of the nuances that we have to keep in mind while we create our models, and also how we store and surface features and data in-house.
Oh, okay. So some of the regulatory differences necessitate, creating your own sorts of tools on top of the feature store, so you can redact things, obfuscate things, version things. I'm assuming when data pulls are requested by federal agencies and those sorts of things. That's a lot to keep track of in your particular use case. Right. Yeah. Right. So in Shelf Engine, when you're looking at the supply chain, what are some of the unique things there that you guys have in your feature store that is kind of a benefit, but is not common, that is unique to you?
Yeah, I think, what's really interesting is hearing Richa's explanation is we don't deal with that at all. We deal with something really different where we don't have PII, we have sales data coming in. It's a lot of transactional stuff. We have a lot of third-party data coming in, but those are things that you can get generally from widely sourced places. So, and the main levers we have on making the product, which is forecasting essentially for grocery and food services, the main thing that makes that work well is not the designing of specialty features in certain ways, but really applying the right sets of models to capture the supply chain complexities or logistical complexities that go on, like labor shortages, vendor shortages, product handling in stores, and all kinds of crazy things like that. Those are the really interesting aspects. And so the feature store for us is really a way to hand off something And going back to Devor's point, what we want to do is create this process where the scientists can kind of like own a particular segment, pass it off, and pass off the early part too. So that way they like own that segment of that cycle, they iterate on that segment, and they can focus their efforts therefore on these larger sophisticated models and configurations of those models to get things in the right place for the product as a whole. It's very different. I never have to deal with anything that Richa is talking about. So
Lucky you.
Right. Oh, that's yeah. And then in telecommunications, obviously, it's different. We have both PII and system telemetry data that some of it we need to obfuscate, some of it we don't. So it's and certainly regulatory concerns as well. So we only have a few minutes left here. So I'm going to ask Patrick a specific question. In some of the clients you've worked with, helping them with feature stores and Rasgo and having or seeing different use cases, do you see any uncommon implementations that you might want to share?
We have one customer we work with that prior to looking for a feature store kind of off the shelf, they had built it all in-house, and it required 5 MLOps engineers to maintain. And in that one, they had data for their features in 3 different data stores. So the like consistent work was just syncing the 3 things back with each other. So it's sort of like it was called a feature store, but really it was like a data layer, synchronization tool at the end of the day. And it sort of crippled their ability to actually build features, right? And actually like promote those to production and serve those to their kind of consumers who are the data scientists. So that's like a specific example. I'd say like avoid that, right? But in general, I think some of the other trends that have emerged is, and we kind of bet hard on this, is like the idea that your feature store could be with the physical data could stay within your data warehouse. And the feature store is actually the metadata abstraction that describes how a column can be treated as a feature. And that's sort of the approach we've taken as we built Rasgo, is that like our customers really want that single source of truth data layer where they can serve their models from the same place that they serve their Tableau dashboards, right? Or their Power BI insights, which introduces sort of other complexity because you have like a much broader user base and there's interesting dynamics that differ, right, between those 2 consumption patterns. But I'm really interested to see if that continues to be kind of a trend that emerges, is like the idea that you can centralize that data in one place and still use it as features in a model.
Perfect. Well, that's really fantastic responses, I think. Good discussion. I'm sure we could go on for quite a long time about all the various, interesting parts of the use cases, the benefits, and certainly the details of everybody's implementations. And to that, we're at time. And I appreciate everybody's time during this panel session today. It's been very fun. Thank you.